Module 6, Lesson 13, Describing Variability Using the Interquartile Range. Lesson 13, Describing Variability Using the Interquartile Range, IQR. I hope you have your underliner ready or your highlighter. The interquartile range is a measure of where the middle 50 is in a data set. It's where the bulk of the values lie. The interquartile range can be used to show what the range of an average performance would be, such as where most people fall on a certain test or what the average employee makes. The interquartile range can be more effective than the mean or median because it shows the dispersion range rather than just one number. Listed below are the counts of the number of French fries for each of the restaurants in Lesson 12. We had Restaurant A, Restaurant B, and Restaurant C. First question is going to ask us to show the median for each set of data. With your partner, I would like you to try to find the median on your own. I'm going to show you now how to make sure you find the median. In the first restaurant, there are 20 bags of French fries that were counted to see how many fries were in each bag. You can go by crossing. You will always find the median this way. However, there is another way to do it. If you know there's 20 bags of French fries, you can divide 20 by 2 to find the median. The median is going to be found when you go in 10 numbers. So let me go in 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now I'm going to go 10 from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What you're going to find is that the median is going to be in between these two numbers because there's 10 numbers on this side and 10 numbers on this side. And this makes it a 50-50 balance, okay? In order to find the middle of those two numbers, you take 80 plus 84 and you divide by 2. The median in this case is going to be 82. Let's use that new strategy with Restaurant B. In this case, there are 19 numbers. When you take 19 and divide it by 2, that is 9.5. Now you obviously can't cross out a half of a number. When you have a half like that, let me show you what happens. You cross out 9 whole numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 from that side. And let's cross out 9 from this side. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 numbers on the lower half, 9 numbers on the upper half. 82 is your median. Restaurant C has 26 values. 26 is an even number, so when you divide it by 2, you get 13. So I'm going to cross out 13 from each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Now I'm going to cross out 13 from the other side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The median is going to be in between 79 and 80. Common sense tells you that it's 79.5, but let me mathematically prove that to you. 79 plus 80 is 159, and when you divide that by 2, it's 79.5 for your median. Okay? So now, let's see what the problem will have us do next. Find the median of the top half of each data set. Find the median of the bottom half of each set of data. The medians of the lower and upper half of the data are called quartiles. Oh, I'm going to circle that word. Quartiles, if you think about the root word, means quarters. So we're really taking the data and we're breaking it into quarters or fourths. The median of the top half of the data is called the upper quartile. The median of the bottom half of the data is called the lower quartile. So I'm going to start with the lower quartile. Over here, I know there are 10 numbers on the bottom half of my data. 10 divided by 2 gives me a whole number of 5. So I'm going to crisscross the other way now. I'm going to cross 5 off on this side. Now I'm going to cross 5 off from this side. 1, 2, 3, 4, 5. My middle, or my lower quartile for the lower 50% is going to be 77. Because when you add 77 and 77 together, you're going to get 154, and 154 divided by 2 is 77. So we've just taken 50% in this lower half and divided it into 2. So this is 25% of our data, and this is 25% of our data, for a total of 50. Let's do the same thing on the other side, which it's kind of easy because you know that there were 10 numbers on this side, there's 10 numbers on this side, because that's what the median does. It cuts it in half. So there's an equal number of data pieces on each side. So I'm going to cross 5 off on this side, 5 off on this side, and my median of the upper half of my data, or upper 50%, is going to be in between 87 and 88. That is going to give me 87 and a half. So I have my lower quartile, my median, and my upper quartile. And now I have 4 equal parts. 25%, 25%, 25%, 25%, for a total of 100%. Okay, let's do the same thing with restaurant B. I know there are 9 numbers crossed out on that side. Okay, 9 divided by 2 is 4.5. And remember, you can't cross out a half of a number. So I'm going to cross out 4 on each side. 1, 2, 3, 4. 1, 2, 3, 4. My lower quartile here is 76. Okay, I'm going to do the same thing on the upper half of my data. 4 on each side. And 83 is going to be my upper quartile. Okay, and again, we've just broken the data into 25%, 25%, 25%, and 25%. Okay? Restaurant C. I know there's 13 numbers on each side of my data. 13 divided by 2 is 6.5. Okay, so you don't worry about the half. I'm going to do 6 on each side. And you're only going to have one median for your lower half of the data, so your lower quartile is going to be 78. I'm going to do the same thing on the other side. 6 on one side, 6 on the other side. My upper quartile is going to be 84. Okay, again, splitting it into 4 equal sections, 25% apiece. Now we're going to go to number 2. That's the whole goal of the lesson. We're going to talk about interquartile range right now. The difference between the medians of the 2 halves is called the interquartile range. What is the IQR for each of the 3 restaurants? So the first thing I'm going to do is I'm going to do restaurant A. Okay, I'm going to take the upper quartile of 87.5. And I'm going to subtract the lower quartile of 77. And I'm going to make sure I do 77.0. When I subtract these 2 numbers, I get an IQR of 10.5. Okay? For restaurant B, you are going to take the upper quartile of 83 and subtract the lower quartile of 76. And you are going to get an IQR of 7. Now finally, for restaurant C, I'm going to take my upper quartile of 84 and I'm going to subtract my lower quartile of 78. The interquartile range for restaurant C is going to be 6. B, which of the following restaurants had the smallest IQR, and what does that tell you? Well, restaurant C had the lowest IQR. And that means there is less variability in the number of French fries in each package sold. Okay, so I don't know, that seems like a restaurant I would want to buy fries from because it means it's going to be consistently have the same number of fries in it. It's not going to have a smaller package or a higher package. Okay, let's continue. Okay, example 1, finding the IQR. Read through the following steps. If something does not make sense to you, make a note and raise it during class discussion. Okay, consider the data. Okay, so what I'd like you to do, I'm going to flip through these screens and I'm going to ask you if you find any mistakes. Number 1, order the data. The data is already ordered. Number 2, find the minimum and maximum. The minimum data point is 1 and the maximum is 17. 3, find the median. There are 17 data points, so the 9th one from the smallest or from the largest will be the median. 4, find the lower quartile and upper quartile. The lower quartile, Q1, will be halfway between the mean of the 4th and 5th data points, 4 and 6. Or 5 in the upper quartile, Q3, will be halfway between the 13th and the 14th data points, 15 and 15, or 15. Find the difference between Q3 and Q1. The IQR is 15 minus 5, which equals 10. Okay, see if that's how you would have done it. See if you can find the mistake. Now I'd like you to try some on your own. Okay, remember, the most important thing in all of these is to make sure that the data is ordered from least to greatest. In these examples, it is not ordered. You have to order it on your own. Number 1. Number 2. Number 3. Number 4. Final exam review. Good luck.